No.
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 We're here.
We're here?
Here.
I
What?
think we're here.
Who pushed the button?
I don't know.
How are we here?
How to do that?
I see some react emoji coming up.
There's so many react emoji. Whoa. We're getting a lot of reactions for not any jokes yet. I'm really proud of it.
Yeah. Low bar.
Nice low bar, which is how we want to start. And
Yes,
also
perfect.
end the lightning talks, maybe at a lower bar even, right? Like just, yeah. So everybody, welcome to the lightning talks. This is one of our personal favorite parts of SciPy. It might be yours or it might not. That's okay. I am Jyotika Monk. I'm one of our hosts, and
I'm David Nicholson, and I'm muted. No, you hear me. Okay. Unpinned. Someone should unpin me. There, that's much better. Yeah.
Nice, you're unpinned.
And I'm definitely not confused, and there's no chaos in the lightning talks. We never have any sort of chaotic energy, especially not after last year. We've reduced the chaotic energy.
There's no chaotic energy. None.
Yeah.
Extremely serious.
Yes, very serious. That's part of lowering the bar. Apparently, I have a job as an machine intelligence engineer at Embedded Intelligence, and I still do lots of academic things related to stuff that I did in a previous life involving birds.
Birds.
So I just had to have something cool on to match Madikin's cat sweater.
Yes, that's right. Welcome to my cat lair, everyone. I'm here. I'm a cat. It's perfect. Do you put a bird on it? Is that what happened, David?
Yeah.
So yes, and our last host is Julie. Julie?
I'm Julie. I don't know. I'm a data science manager at Mozilla. And Madikin's shirt will eat David's. Yeah, I'm the neutral party here since I don't have any animals on my shirt. Unfortunately,
You could. Maybe her shirt will evolve. Who knows what tomorrow will bring?
Yeah, you never know. It might be animals. It could be stuff.
I think your shirt could evolve, like in Pokemon, like Pikachu can evolve.
Ooh, yes, yeah. Ooh,
the unofficial mascot of the Lightning Talks since exactly last year.
Yes.
We have to go down the list of inside jokes so everyone can be in on the jokes.
Yes.
Dylan helpfully mentioned that queso is a really critical component to the Lightning Talk series.
Yes.
For folks that are new to the SciPy conference, the last many years of the conference has been in Austin, Texas, and only 1/3 of our hosts for the Lightning Talks are in Austin. And I did indeed have queso for lunch.
Today?
But nobody else.
Every day.
Today and yesterday.
And every day before that, but
no need to brag. So this is we'll have a queso fountain somewhere for you.
So this joke started because we dreamed about what, like, SciPy usually has treats around, which you might see in the Gather Town, and we dreamed of what would be the ultimate treat at SciPy, and it would be a queso fountain. And Julie likes to tease us all who are not located in Austin that she has access to queso freely and most availably. So another inside joke is that some people really like Linux. What year is it, David?
You set that joke up with violence, Madikin.
There was no, how is it violence when I say some people?
Some people, like Paul Ivanov, who traditionally would make a joke about it being the year of Linux on the desktop in the middle of Lightning Talks every year. This year, as we learned today, it's the year of Linux on Mars.
Ooh.
Right?
Penguins
on Mars. Gentoo on Mars. And snakes on... No, Python...
Snakes in space.
Space, yes.
Space snakes.
I can't even make a callback to this morning's talk.
Wow.
I think
Wow,
we should let someone else talk now.
Yeah. So also since we're the host, we're just going to make jokes about all the talks. When you give a lightning talk, the lightning talks can be anybody. You sign up randomly. We're handling the sign up for the lightning talks in Slack. So you can check the channel there and sign up on the Google form. You don't have to really prepare this in advance. You can if you want to. And we want lightning talks to be something cool that you maybe did with Python. It doesn't have to be your work. It could be like, hey, I really like burritos. Let me talk about burritos. Or it can be something else. Like if you have some cool cat package. I mean, some people like cats, I guess. So you could do that. Yeah, so I think it's pretty good. And we also are going to have a BOF later, hosted by Tracy Teal, about how to give a lightning talk. So if you've never seen a lightning talk or you're a little nervous about doing it and you want to get some instructions, you should go to the BOF.
Yeah.
Wait, that makes me think of a segue that we set up earlier.
What?
Yeah, and the segue is, Madikin, how would I get to the BOF?
Oh man, I don't know. Julie, do you know how to get to the BOF?
You know what? I might. And in fact, perhaps I could give a lightning talk about how to get to the BOF.
Whoa.
Whoa!
That's
We did
meta.
it.
BOF lightningception.
All right.
So also, just to give you all a warning, we give a hard stop at 5 minutes for the lightning talk. I'm going to start harassing you at 4 minutes, 30 seconds if you're going overtime. And I do have boot privileges, so we can boot you from the stage and kick you out of the lightning talks if you're going way over time. So Julie's going to go. I think she's not going to go over 5 minutes. If she does, who knows what I'm going to do. And then
out of the lightning talks.
Yeah. And then next up, then we also are going to say who's on deck, which means the person who's going after Julie. So that person we're going to invite up on stage. They're not going to be presenting. We're going to mute you, but that you can you don't have a lag when we bring you up, that we can switch straight from Julie's talk to your talk.
So the person on deck
will be Eyal.
Yeah.
Thank you, Julie. And we encourage people, we will make dumb jokes because that's our talent as a lightning talk host. We encourage you to continue to make dumb jokes in the chat. They will, of course, be respectful and supportive and obey the queso of conduct.
Ooh, nice.
Almost a joke.
Don't get too spicy. Yeah. So y'all, we're gonna mute you and screen mute you just while Julie's giving her talk. But then once she finishes, you can unmute. Okay?
Yeah.
Sorry. So I'm going first. I didn't follow.
No, you're going
second.
after Julie.
Yeah.
Okay.
Yeah.
Cool.
I love it. We're starting with some chaotic energy. So if you can unshare, and then I will tell everybody how to get to the next thing after this, which, yeah. Oh, cool. I'm getting pinged on work Slack that I definitely forgot to mute.
No.
It's okay. It's fine. Let me remember how presentation works. Okay. So let's talk about Conference Zelda SciPy 2021 edition. But like last night, what I realized, so the platform that we're going to do Boston as well as posters and some of the networking sessions is different than AirMeet. And so we wanted to like explain to you all how it worked. But last night at like about 11:30 p.m., I had this realization that this isn't really Conference Zelda. This is Conference Edition Stardew Valley co-op mode. And so let's talk about how this works. So again, this is actually Gather is the platform, but it's way funnier if it's Stardew. And I may or may not have put like 1,000 hours into that game. So the sign up, in order to sign up, there are a couple links. They're all over the place in AirMeet, and then we're also in Slack. And you just click on the link, and it'll take you to the sign up screen. And it'll let you enter your name, and then you can choose a character of your liking, and you can choose its clothing. And then It'll ask you permission to access your camera and your microphone, and then you can gather. Oh no, it's going to play twice. The first thing that happens is that you're dumped into like about a 15-second tutorial. It's kind of nice because it shows you like sort of high level how to do like the basics of moving around. But maybe let's talk a little bit more tips and tricks and how you can navigate this space that we have set up. So we have two main spaces. One is inspired very heavily by Caltech, and then the other one is inspired very heavily, but let's say loosely, by the AT&T Conference Center. And so they're kind of big, and if you get lost, you can go to the little like hot dog thing on the bottom and click on the mini map, and it brings up something that shows you where you are in this space. There are a lot of objects, and if you walk towards them, they'll highlight in yellow, and you can interact with them by pressing X. So here is what it looks like. So you press X, you see this like little message, and then you learn more about the conference or the space. And that's playing twice. Cool. Like I said, we have two spaces. So we have the AT&T inspired space, which is the one that we're starting in. And then if you see that red curtain, that will take you a portal to Caltech. And it really must be a magical portal because it's taking you from Austin to Pasadena. And so this is how you interact with this portal. So you have to hit the enter key. It asks you for your camera again and like permissions, and then it'll pop you somewhere in Caltech. So in GatherTown, one of the reasons why we really love the platform is because you can have conversations and talk with other people. So let's go through some of the rudimentary interactions with other conference goers. So you can have conversations with people. So the way that you do this is you have to get like physically close in pixel space to have these conversations. And there's like a 1/r² thing with your video. And so let's see what this looks like a little bit. So as you can see, the avatar is getting closer, and then you can have a conversation, and then as they walk away, they fade out. It's a little inconvenient if you're trying to have a conversation and move to a space at the same time, though. So you can follow and locate somebody. So if you want to talk to somebody as you go to around the conference space or to a new space even, what you can do is you can open up the menu on the left-hand side, find the person that you're interacting with and right-click, and then you can follow them. And so that means when they move, you'll move, and so you can keep having your conversation. You can also locate people on a map, and if you can't see them, and then it'll draw like a nice thick line, and then you can follow all the way through. Let's see. Oh, I never fixed this, sorry. So there are also this notion of private spaces. The yellow arrows roughly correspond to where they exist on this image, but they're darkened. And as you enter a private space, you can have conversations with people. And the space will become bright, and then the rest of the screen will dim. And so in this instance, Colby and Kyle are having a conversation in a private space. And as I walk by, even though I'm close enough to both of them where in principle we should be having a video thing pop up, they get to have their conversation quietly. And so this is what it looks like for me. Queso? Oh no, are we running out of time?
Oh no.
Oh no.
Oh no.
Oh no.
Oh no, you're out of time.
This is what the posters look like. Press X to interact. I'm going to skip this. For BOFs, we'll be in rooms. The speakers are on the stage. There will be a Q&A space. So if you look, there are podiums. People who have the orange thing are presenting to the entire room. And for best practices, if you're sitting next to somebody, they can hear you and see you, as well as hear the speakers. So we're asking everybody to mute their videos and cameras unless you're really trying to have a conversation in the space. And with that, thank you, and please come to Tracy's How to Give a Lightning Talk BOF for tomorrow and Friday.
Yay! Thank you, Julie. So I have a question. Is this like following people around? Are we going to make a conga line? Is that what's going to happen?
I've
I'm
never
ready.
tried that. You could.
Yeah, I think it would be great. I mean, like a gather conga.
Yeah, let's see if we can break the platform.
Ooh, a conga. So I have a question before we start presenting, y'all, which is from Gil, which is, can we get a poll to check on desired amounts of chaotic energy? Well, Gil, it's like you read our minds.
You ready? Oh no.
Oh no, some people added polls. Julie, did you add it?
It's going. So do we need chaotic energy? Oh, people are voting.
Oh, nice.
Yeah.
Should we add one more? Just because
I see a lot of people replying yes.
I see a lot of yeses, a lot of initial yeses. Yeah. Okay. Should we do maybe one more?
Yeah, that's.
Deacon, you control the polls. Are you putting one up?
No, Julie was
I just
controlling
put one up, another one up. What is the best color map?
Ooh. We have a nice email option. I'm into it. Also, we can't influence the results as hosts, just to let you all know. So don't worry.
I really want to vote for Jet.
I really want to vote for sepia because I'm all about that sepia. Yeah. Okay, Ayal, so do you want to get started? And we will, I'll harass you in 4 minutes, 30 seconds.
Sure. Hi, everyone. Can you hear me?
We hear you.
And can you see my screen?
Yes.
Okay, great. So hi, everybody. I'm glad to have this opportunity to talk about something I'm really passionate about. It has to do with the topic of causal inference, which you might see more and more popping up in conferences these days. Just 10 minutes ago, we heard a talk about a package called DameFlame that applies causal inference in data analysis. So you all heard that correlation does not imply causation, but still we're interested in knowing, can we actually infer the causal relationships between parameters? And the answer is maybe, and it depends on how you analyze your data. And this is something that I am not an expert in. I'm actually started learning this a few months ago, and I've been using my Python skills in order to make progress. And so that's what I'm presenting here in the poster, the concept of something called Simpson's paradox as a gateway drug in order to learn about causal inference. And what I mean by that is that it's a misinterpretation of data where the interesting aspect is that you can get a result for a whole population outcome, and you can find that it's in conflict with its cohorts. And what I mean by that is, for example, you can imagine that you're doing a drug trial. Think in terms of like a random control trial, and you get for the population a result of 14% beneficial, but then it's harmful when you break it to its cohorts, like males or females. And that's really not intuitive, but it is plausible to get this within your data. So how do you cope with it? Well, the first thing you have to appreciate is that you have to worry that you might get the wrong conclusion, right? Because on the one hand, one way of slicing the data, you say it's beneficial. On the other hand, you say, oh, it's actually harmful. And so that's the nature of the paradox. And the solution is quite simple. It has to do with confounding factors. And so for this purpose, we heard talks today about Streamlit. And so I created actually an app via Streamlit in order to slice and dice the data. So here you can see I created a data frame and a nice visual of this paradox. So this is this population, it's minus 14. That means that the drug is harmful, whereas over here you can see per population, male, female, we can see it's actually beneficial. And then I can play with the parameters and I can start solving for it. And so that's what I kind of like teach in this like tutorial that I created within Streamlit. And so within this poster, what I present is this topic at large and how I suggest approaching anybody's, once you understand the concept of Simpson's paradox, how do you continue to learn? And it's a very interesting topic, and I recommend there are a few streams of thought, and I like the ones I learned Judah Pearl's, and so he has this nice causality ladder where he points out the difference between seeing, doing, imagining. I'll be here all week. I'll be glad to talk about the contents more, and I'll just summarize with main points of this topic. I'm actually going to present this in Eurocon end of this month, so you're kind of guinea pigs of me first time presenting this, because again, I'm very new to this topic. And yeah, so just to summarize, Simpson's paradox is a situation in which you can misinterpret your data when the population outcome is in conflict with those of the cohorts. And so you have to worry about getting wrong conclusions. And in order to solve for this, we can use confounding factors. We have to control for confounding factors. And by mastering identifying the Simpson's paradox and solving for it, that's can be considered as your first step to learn about causal inference. So yeah, I'll take questions from here.
Well, we're not going to do questions with lightning talks, actually.
Oh, sure.
Sorry about that. Lightning talks generally is just you presenting your work, but people can come see you afterwards at the GatherTown or at your poster. Or, you know, you can just ask questions into the void. Like, that's truly the chaotic energy we're looking for in the lightning talks. Or, you know, make sure it's to thunderous applause.
Sure. Cheers. Thank you very much. I'm just going to share my slide again for those who haven't seen it.
Thank you for your humorous introduction to causal inference.
Wow.
Wow, beautiful. Yeah. Wow, so good. So I forgot to ask who is on deck next time, but who's up, David, and who's on deck?
Yes, so who is up is Juan Luis, who
is here.
Has helpfully brought up.
Yeah. And on deck?
Will be Sarthak. Yes. Thank you. Sarthak, who we will find in the People tab.
Okay. And while that's happening, I'm going to publish another poll.
Yeah, that's the most important order of business right now, I think.
Yeah, I think everybody needs to, you know, do that. Get ready.
I think we need a cheese poll soon.
Ooh, that sounds like a great idea. Do we want to maybe discuss some of our great package ideas about cheese? Like, I think somebody should make a cheese image generator based on other cheese images. What do you think, David?
Oh yeah, you're talking about AI cheese generation images? Yes. Now, you know,
this is what
there's the generative adversarial cheese, which is an algorithm that a lot of people haven't heard about yet, but it's pretty cutting edge.
Yeah.
You know, I mean.
But is it adversarial or is it more like a big friendian?
Wow, that pun is so bad I can't even think of any generative adversarial network cheese puns. That's just big friendly.
Right. It's such a big topic.
Right.
I think Juan, do you have your presentation ready?
Yes.
Cool.
But I think these jokes were just taking off, Juan. I don't think we should switch over to something actually, you know, informative. No. We're really on a roll. In comedy, this is called riffing. I don't know if you're familiar with.
What?
No, I'm just kidding. Please.
Juan.
We lost Juan at that crucial moment.
Oh no.
No, Juan.
Wow, it's probably not adversarial cheese.
Sorry.
I think my adversarial cheese drove Juan away, but
we can. Sarthak, if you're there, maybe if you want to present, and then whenever we can get one back.
Yeah.
Wait, sorry, I lost.
Oh, are you back? No, you're back.
I'm
sorry.
back.
Okay. Does it work?
Are we ready?
Yep.
Yeah. Take it away.
Okay, let's go. Okay, so I'm a big fan of queso as well. So let's try to see if we can bring some of it to Mars as quickly as possible. And in fact, let's try to see if we can bring some queso to Mars in 5 minutes. So, big warning ahead. This is rocket science, actually, but don't be afraid. We're going to make it very easy. Otherwise, we wouldn't have time to do all these things in 5 minutes. And also forgive my poor setup. My fancy OBS didn't work because it's the year of Linux in the desktop. So I have to ask with the question you're all asking yourselves, what is astrodynamics? Well, I'm glad you asked. So astrodynamics is a branch of mechanics, which is itself a branch of physics, which studies practical problems concerning the motion of rockets and spacecraft through space. So for example, you can see here a depiction of the trajectory that Rosetta, the European mission, did to arrive to an asteroid some years ago. And as you can see, it involves what jokingly we refer to cosmic billiards, because it had to turn around the sun a few times and then pass near the Earth and Venus and so forth. So it's a little bit complicated to optimize these trajectories. And what is Polyastro? Well, I'm glad you asked as well. It's a pure Python library for astrodynamics. So let's go to Mars, shall we? This, in line with the talk that we saw this morning, this wonderful keynote, I brought to you the Perseverance trajectory. It happens to be much simpler than the one that we saw before. So it's just a simple arc between the Earth and Mars. We're going to see how to define such orbits. First of all, we have to import the natural bodies from Polyastro, so the Earth, Mars, and the Sun, and also the orbits. And the way we define it is by specifying the position vector and the velocity vector. Thanks to the wonderful AstroPy units, we don't have to worry about messing up like imperial units and metric units, which is something that some companies like to do from time to time. And with a single command, we can define that we have an orbit from the Earth with this position and this velocity. In fact, if we want to plot it, thanks to the amazing Plotly library, if my kernel responds in time, yes, we do have some simple interpretation of the orbit. And in fact, we could have as well use the 3D representation. So we can have some more interactivity here, and I can zoom, I can pan, I can rotate, and so forth. Then we have to locate the planets. For that, we're going to use what we call ephemerides from JPL, from NASA, which do a wonderful job of trying to locate the planets in a very precise way also for the future times. Then we're going to say, okay, so the date of launch is 13th of July 2020 at 11:50 UTC. So this also gives me a representation of what the orbit looks like. This is the position of the Earth at that time, and this is the velocity. We do the same thing for Mars, and we define this quantity called the time of flight. So essentially, how much time do we need to go from one place to the other? Secondly, we solve what we call the boundary value problem, or the Lambert problem in astrodynamics speak, which is what trajectory exactly do I need to go from the Earth to Mars? And this is the arc that I'm going to describe around the sun. Then I'm going to propagate all that arc so I can have a nice plot of the orbit. By the way, this is actually really fast, thanks to Numba. I did some comparison some time ago, and it was at least more or less in the same order of magnitude as Fortran, but it made me a happy person because it actually worked on Windows without having to scratch my head too much. And third, we finally go to Mars. So we're going to do some boilerplate here. We're going to plot the position of the Earth at launch, the Mars at arrival, and my trajectory arc. And here I have the arc that the Perseverance rover described while going from the Earth to Mars. And finally, and I hope this works, let's bring some chaotic energy here. We do a slider with SciPy widgets. And finally, yes, it looks like it works. So now I can interactively change what's the time of flight. So for example, if it's going to take me more time to arrive Mars, then I can slide this slider to the right, and you see how the trajectory changes over time as it gets longer and longer in the arc. So that's it. Thank you very much. Here you have the documentation. You can hit me an email. I'll be around for the rest of the conference, and see you on Mars.
That was great. Thank you.
Perfect timing. Perfect timing.
Thank you.
Yeah. And so I think what I took from your talk is that next time the Mars helicopter will just be completely piloted by a polyastro.
Well, we're going to get there with Polyastro, but then we leave the rest to F prime and automatic generation.
Very diplomatic answer. Okay.
Mm-hmm.
Thanks, Juan.
Thank you.
That talk was out of this world.
Yeah.
Wow.
Yeah.
Wow.
Good one.
It was a meteoric rise in discourse from our cheese puns.
What I liked about it was so dynamic.
I'm glad I didn't space out. Like, I wasn't ready. So also I want to give everybody a little update, which is that the polls, the first ones we gave were not public because you have to check a box saying to share them. So we're just going to tell you all that you all were good and chose Viridis as the #1 color map. But, and that, yes, we need chaotic energy. Everybody's into that. And shortly after Viridis was random and p.random. So enjoy your random color maps, everybody. And then everybody really likes bubble wrap as packaging. So nice. I find it like stimulating, you know, but I'm going to make it fun. The next polls are public, so you should be able to see them.
Excellent. I'm glad we could all agree on bubble wrap as a publishing standard, as a packaging standard. Should we let Sarthak take it away?
Yeah, I think so. And bring whoever's on deck next.
Yes, Matthew will be up next, and Julie's already got him ready to go. So Sarthak, you should be able to share your screen.
Great.
Excellent.
Can you guys hear me and see the screen?
Yeah, you're good to go. Take it away.
Perfect. Great. So I'm Sarthak, and I recently just graduated my PhD in Material Science and Engineering from University of Washington, and I'm going to be joining as a data scientist at Palo Alto Research Center at the end of the month. So today I want to briefly talk about a package that I've been working on. It's called Seaborn-image. It's for image data visualization. It's a high-level interface for drawing images, and it's based entirely on Matplotlib. And as the name suggests, it is heavily inspired by Seaborn. Basically, I wanted to create something that was for images, but was very similar to what Seaborn had done for statistical data visualization. And you can check out the project on GitHub. It's Seaborn-image. So a few key things about the package. Again, it's Matplotlib at the core, but it provides a more high-level API for working with images, or mainly plotting images and different kinds of visualizations. And since it's based on Matplotlib, we're using the well-tested backend of Matplotlib. The goal is to make the complex visualizations as easy as possible. So some of the examples of Seaborn-image are, for example, say you want to plot an image. Here we're loading a sample data set of a polymer. And to plot the data set, you would just call Seaborn-image.imageplot, pass in your NumPy array. And since we want our image visualizations to be more descriptive, Seaborn-image also allows for easy additions of things like scale bars, color bar labels. So here we can just specify what the individual pixel size is. Here it's 15 nanometers per pixel. So we just specify dx as 15 and the units as nanometers. And we can also specify the color label as whatever, in this case, it's height and it's nanometers. So that creates, that plots an image using Matplotlib, adds a scale bar, adds a color bar, adds the color bar label without a lot of additional boilerplate code. And a lot of these things are further tunable. So you can modify the image and other related properties really easily. Say you want to modify the position of the scale bar or the color of the scale bar or how thick the scale bar is, you can just call set scale bar and modify these properties. You can do this for the image as well. You can set your color maps, you can set the origin and all the basic things for images. You can set context, you can reset the defaults and basically anything related to settings for images. Some other things that you can do is say you have some outliers in your data. Real world data is never perfect. So here we're plotting sample data that has a single point that's an outlier, and that's rescaling the entire color map. But you can really easily correct for this using a parameter called robust, and you can pass it to true, and that will scale the color bar accordingly. In this case, we're setting it to 0.5 to 99.5 percentile of the data, but you can further modify this using the perk parameter. What it also does is it automatically adds these extensions to your color bars. Again, the whole idea is to give you a more high-level API to make your image visualizations quicker and without a lot of the boilerplate. You can also visualize the distribution of your data really easily. So here we're just calling image hist on the NumPy array. In this case, again, the polymer. We're setting the orientation to horizontal because we want the horizontal version of the plot. Again, passing the scale bars, the color bar labels. And one thing to notice is that a lot of the parameters that we're passing to these functions, they don't really change between the between individual functions. So image plot, image hist has almost identical parameters. So just switching between different kinds of visualizations is also relatively easy.
Jet is coming for you.
You can.
30 seconds. I'm
Oh,
gonna keep
sorry.
coming, but there's going to be some other color maps very soon.
Multidimensional, you can also visualize multidimensional data. In this case, you can call image grid on a 3-dimensional data set and pass in height of individual images, as well as how many columns you want. You can also specify which axis you want to unravel along. So in this case, we're unraveling along the last axis. I'll move through other things. But you can check out the project on GitHub, and if you have any questions, you can reach out on GitHub or Twitter. Yeah, thanks.
Yay! Thank you.
Thank you, Sartak. That was great.
So
got a lot of positive feedback in the chat. We stopped making jokes because we were all saying that it looks like a very friendly API.
Yeah.
Thanks.
I was still very dedicated to coming up with jokes. I thought you could have tried calling it just Seaborn, SEEBORN. Or how about
Bjorn, and then it could be a bear-related package.
Right.
That would be way too chaotic.
Right. Right. You can just rename it that just during lightning talks and then change it back immediately.
Yeah.
That doesn't mess up any of the dependencies. It's fine.
Right. No, it's fine. Just package it in bubble wrap.
Yes.
But yes, people should come to your poster and hear the whole spiel. And now we'll let Matthew take over, who so far has had the best pun, I think, in the Lightning Talks Slack channel. He said, "I'm bready."
Oh.
Like bread.
What?
Like bread.
Wait, what?
Are you ready to give a talk? I'm bready.
Oh, what? Oh, bread. Was it? but was it cheesy enough?
Right. Yeah, it's true. Well, I mean, you either. Some people during their last year, they took on sourdough, and so they're ready with bread puns instead of cheese. So I think we should.
Oh, I see. Okay, yeah.
I'm in deep trouble for this.
Ferment it a little bit longer. That's all.
Matthew, come back tomorrow when you have a cheese pun, and then you can give your lightning talk.
Yeah.
I'm just kidding.
No, I was about to see, I'm in trouble. Usually at work, they tell me to control my chaotic energy because I'm the guy with all the puns and chaos. Here, I feel like I'm being encouraged to bring my
we're
game.
just, yeah.
We're chaos enablers. That's our job.
Okay, fair enough.
I mean, that's lightning.
Presumably
Chaos Lightning. So it's all you.
Yeah, we'll let you take it away, and please be on 1000% chaotic.
Okay. Can you guys see my slides?
Yeah.
Awesome. Okay, so my name is Matt. I'm representing my team and I'm presenting our project in programmatically identifying cognitive biases in software development. I have a lot of things to say, not enough time. So if you actually want to learn about this, check out the paper because I'm going to be prioritizing the puns over the actual education. That's my takeaway from all this. But basically, I think if anyone has been to a Python conference recently, you've probably heard this talk about, machine learning and artificial intelligence being incredibly more and more biased, and how do we control that? A lot of great companies and academia researching this. We thought to come from a different perspective, and that's, can you look at commit messages, code comments, code doc strings, and can you look at those actual messages and find biases in those artifacts? So we actually took 3 different software projects, 2 internally and 1 from an open source dataset, and we tried to annotate them for bias. The 4 types of cognitive biases we tried to research is anchoring bias, availability, confirmation, and hyperbolic discounting. These are all the types of biases that will sort of have you jump to conclusions based on available information. Like if you see a code comment saying Queso sucks, you might automatically assume that's the worst programmer alive, yada, yada, yada. That's potentially probably a form of cognitive bias. There's a 5th category we called for subjective or other. And that's just a bias that really isn't a cognitive bias, but it's just something noteworthy. So this data set doesn't exist. No one, to our understanding to date, has labeled code artifacts for bias. So that was all on us. So we had a team of 5 to 6 reviewers annotating each of these artifacts using Prodigy for one of these 4 particular types of biases. If reviewers ever conflicted, there was a secondary review process to sort of determine which label was the more appropriate label. In the graph on the lower right, lots of information. Your biggest takeaway from that is reviewers tended to agree when something is biased, that's the bias on the left, but reviewers often disagreed on why it was biased, the specific type of bias, that's the bias on the right. We'll get to how that's really important later. And then just one quick slide before we jump into the results. We just used this basic PC NLP model to do all of this. So model results. We first thought, humbly, like we could do a multi-label model trying to predict a particular type of bias. We realized though by doing that, because most of our data was not biased, everything slanted down that angle, first of all. And not only that actually, but because sorry, the lawnmower is going outside. Perfect timing.
No, that's okay, Matt. Can I really quick? I think we're still seeing your title slide.
What? I was switching between slides this whole time.
Yeah, I'm sorry.
No.
I just.
Let me try sharing again this time.
Sometimes PowerPoint's a little tricky.
Yeah. Do you see anything different now?
Yes, that's better. That's much better.
Okay, got it. You missed all my case. Okay, anyway, these are the 2 projects that we did on the Kurzweil dataset. The 4 types of biases we did was anchoring, availability bias, confirmation, and hyperbolic discounting bias. We used Prodigy to do the review process and all of that. This is the diagram of the model. Nobody cares. I hit a last-minute Queso pun there. Model results. Okay, the real most important slide of them all. Basically, when our model tried to predict on the particular types of bias, the model did really poorly. We believe that's because the humans, first of all, disagreed on when something was biased in the first place. And also, we just had a lot of our data was just not biased to begin with. So we sort of top, like, is it biased?
We lost Matt.
Oh my goodness.
Wait, we lost you for a second,
really?
Matt. Yeah, sorry.
I'm back now.
Yeah,
okay.
Can you try sharing one more time? Let's just let you.
I will. Yep. So sorry about that.
No. We're all getting used to the
back now?
platform. Yes, we see your confusion matrices.
Okay. Binary models. We ultimately tried just predicting, is it biased or is it not biased? We got far better F1 scores. We actually made guesses on both sides. So for future research, we'd like to sort of investigate more with collecting more data from different code commits, as well as perhaps investigating in the prior models, like, when the models did not predict a particular type of bias correctly, is that the computer's fault? Is that our fault because we disagreed on why something was biased? So that's all I had. I will be at the poster session later today if you have any questions. Sorry for all the technical difficulties.
Oh, Perfect timing. I was about to start doing chaotic things to you.
Oh, really?
Ready.
Yeah.
Okay.
That was
Excellent.
great in spite of the technical difficulties, and it's the MCs need to practice helping the speakers out more. But
Yeah.
so thank you for dealing with our chaotic energy, and extra bonus points for adding all of the cheese jokes. As Dylan pointed out, this is in proceedings, so people should go read it, because definitely a relevant topic for all of us.
Yeah.
There were
And I
no
like that there was
case or puns
confusion-
in the proceedings. I'm sorry.
Oh, but I like that there was confusion matrices both in our lives and in the talk.
Right.
So, yeah.
So you handled them very well.
Yes.
Right. Thanks.
Thank you.
Thank you. And now that Jyotika, who Julie has lined up, and will you please tell me how to pronounce your name correctly? I've slaughtered everyone's name.
Absolutely, no, I don't blame you. So it's Jyotika.
Jyotika, thank you.
Of course. Can you all see my screen and like the full screen slideshow version?
Right now we see your presenter cues too.
Oh, well, I don't have any, but I still want a better display for you guys. Can you see that better now?
Oh, it went away.
All right, let's see.
I think if you try to reshare, it might.
Yeah, let me try one more time.
Oh, hey, while we're trying, one extra announcement about BOSS. You cannot use Safari. And I'm not just saying that because I work at Mozilla. It doesn't render all the images that you need to understand the space. Just heads up.
Unless you want real chaotic energy. But, you know,
True.
like, we could encourage, but Julie's trying to do you a favor.
Yeah. Okay, this looks much better, Jyotika. So.
Okay, great. Awesome. So thank you very much. I'm going to talk about social media analysis using natural language processing. So I know this is only 5 minutes, so I'm going to power through most sections here. But who am I? I'm Jyotika Singh. I work as a director of data science at i6 Media. It's a content and audience intelligence company based in Washington, D.C. Just linking social media links there if anybody has any questions after the conference. Also, this is a poster session as well, and it's in the proceedings, so you'll get more information there as well. So social media language, I think the perfect term to put it is it's chaotic, right? There are no rules. The way people communicate can be really so free-form. You can use emojis only, all caps, all lowercase, just no rules around case, combination of text and emojis. And then, different languages, in addition to non-standard abbreviations. So like ESY for easy and UH for UR. So it's really all over, and that is what makes it even more challenging to perform any NLP tasks. So to solve for them, there are some solutions that work really well, and really depends on the tasks, the amount of cleaning you want to do to your data. So some basic things can be remove any URLs and emojis or any excessive punctuation, so clean off the text. A very popular method is also only to retain alphabets and spaces, again, depending on what your model commands. Other popular things could be spelling correctors. If you only want a particular language in your model, you can do language detection and translation. Once you detect the language, it's really up to you whether you want to remove that from your data set or really translate it and use it in different ways. One other important thing is text normalization. So, for example, Washington, D.C. can be said in so many different ways. D.C., Wash, D.C., District of Columbia. Just very variations, and some that you can't even capture because it's just people's different style of saying things. So really creating a map of mapping some of these terms to what they potentially could be often helps in some NLP tasks. So my primary focus here is going to be on YouTube and how pulling data from YouTube gives you some social media data and then some NLP operations that can be performed on that used in conjunction with the statistics that we gather from YouTube to perform a trend analysis. So to use the data API, there are some great documentations that are on YouTube's official website. So really following that should be a cakewalk. They do a great job in listing out everything perfectly. There are some gotchas, though. Every registered project that you have with the Google YouTube API has certain rate limit associated. So you can't just keep requesting data from YouTube. Secondly, it's error handling. So let's say you're running something in a loop and you come across a video that you're trying to get data for, but they have turned their comments to private. So anything like that is something that's blocked by the API for obvious reasons. But then it throws you an error rather than a warning. So if you're doing things in a loop, that is not a situation that you would want to be in. So there are some of these different things that I've experienced while using this API. And there are ways to interact with it. And one is just to follow the documentation and build something of your own, or just explore how it looks using their web explorer. What I want to highlight here is this open source tool, YouTube Analysis, which is a work in progress. And I've been really adding things there as I'm noticing gaps. But what it can help you do is interact with the YouTube API, define any keywords that you want to search for, get videos for. It'll get you back statistics, comments, video, text data. You can also define a time frame that you want the search to be geared towards, and error handling is all taken care of. It also consists of a lot of these NLP, the social media data cleaning methods that we spoke about earlier, and automatic report generation, along with key phrase extraction and named entity recognition. So quickly going through an example of how that looks. We know travel in 2020 was impacted, especially March onwards. Let's see what travel blogs on YouTube convey about that. So the trends look increasingly engaging until 2019, and then something happened in 2020. We know what it was, but it certainly impacted the videos as well. All right, powering through. So this is just a diff between 2019 and 2020, and this shows a change in terms of user engagement in travel vlogs on YouTube. And this is surprisingly not surprising at all. It correlates really well with flight searches trends. People are still making content, and what was that in 2020? Hiking, walking tours.
Hiking.
Almost there.
Oh.
Locations mentioned with the help of extractions from comments using NER, and people really inquiring about COVID. Performed all the analysis using Pi YouTube Analysis library, and there is a resources slide here as well for all the other great tools that can help with doing NLP on social media data. Thank you.
Yay. Okay.
Great. Excellent. Thank you.
Great.
Yeah. Okay. Two NLP talks in a row. Clearly, NLP has taken over SciPy, and yes, definitely some needed tooling for dealing with the YouTube API.
I just can't. NLP is just so hard to pun about. Like, I can't.
It's hard to parse out a joke.
Huh?
What? No. Oh, I said it's hard to parse a joke.
Oh.
I get no jokes.
We're working on it. We're working on it.
I'm just kidding. Thank you.
First, we have to project the vector of the joke down into an embedding. It's really fun. First you have to tokenize the joke, and then okay. But okay, I see. The NLP puns are just dumping into the chat right now.
Yeah, we need some assistance here. The true chaotic energy of hosting is getting assistance.
But thank you, Jyotika, and I will try to tweet out sort of a thread later with links to everything. And now we're gonna let Tetsuo come up to the stage, who was the first Lightning Talk speaker last year.
Yeah.
So he's made it through the chaotic energy and is like, I'm back for more. So, which
I mean, that's what I say when I see queso too. So it seems like it's ready to go.
Yeah. So we'll let you share your screen, Tetsuo.
Can you see my screen?
Not yet. We still see me pinned. I'm gonna unpin myself. That, perfect, now we see it. You have a round of screen sharing applause. So we'll let you take it away, and Deacon is ready to start making vaguely threatening noises in the background at 4 minutes and 30 seconds.
3 メーターセコンド。 Can I start?
Yep.
Yeah. Hi, my name is Tetsuo Koyama, and today I will talk about visualize 3D scientific data in Pythonic way like Matplotlib. And first, let me introduce myself. I am Tetsuo Koyama, and I am a mechanical simulation software engineer and staff of SciPy Japan 2020 and PyVista developer team member. And I love science and Python and anime and manga. And my Twitter and GitHub accounts are tkoyama010, so please follow me if you like this presentation. Do you want to visualize 3D scientific data in Pythonic way like Matplotlib? If you want, this slide is for you. And this library is VTK for Human, a high-level API to visualize toolkit. And 3D plotting made simple and built for large complex data geometries and mesh data structures and filtering methods for special datasets. In code listing 1, we demonstrate the hello world of PyVista. The basic step of PyVista script is the following. The first, import PyVista, then generate the mesh and add it to plotter object using add mesh method. And then we can check the render view using the show method. PyVista class hold method to apply general filters to any data type. A user can easily apply common filters in an intuitive manner. For example, code listing to shrink the individual faces of a mesh using shrink method. We can, of course, rotate the mesh about the axis. Let's rotate a mesh about its axis. In this model, the x-axis is from the left to right, and the y-axis is from bottom to top, and the z-axis emerges from the image. The camera rotation is the same in two images. Rotate the mesh about the x-axis every 60 degrees, and we can plot it. Plot the mesh rotated about the y-axis also, and z-axis and custom axis. Code listing 7 sweep polygonal data creating scut from line using the extrude rotate method, like figure 7. And also loading a mesh is trivial. If your data is one of your many supported file formats, simply use PyVista read to load your specially referenced dataset in a PyVista mesh object, like coding list 8 and figure 9. Also note that we can export any PyVista mesh to any file format supported by Mesh.io. To save the PyVista mesh using Mesh.io, use PyVista save Mesh.io code listing 9. Attribute data value that lives in either the nodes or cells of a mesh in PyVista. We work with both point and data and cell data and allow easily access to data dictionaries to hold arrays for attributes that lives either or on all nodes or on all cells of a mesh. Meshes can have a scalar field extracted using warp by scalar method like code 10, and also can have a vector field extracted using warp by vector method, code list 11 and figure 11. Add mesh method can use a matplotlib and custom color map when plotting scalar values. And there is also a camera class of virtual for 3D rendering. It provides a method to position and orient the viewpoint and front focal point. Convenience method for moving about the focal point are also provided. Code listing 13 created a camera and fluxsum, then created a scene to inside fluxsum adding camera object to plotter object. It can be plotting over dataset over circular arc through that dataset using plot over circular arc normal. And I would like to thank you, PyVista developer team.
Oh, no.
If you want to know about discuss PyVista more, please join GitHub discussion. Thank you.
Perfect. Thank you, Tetsuo. Very nice. Great talk to finish us out. So we had some 3D cows. We're trying to figure out, is a spherical cow the same thing as a toroidal bunny?
Great questions.
Yeah, see a lot of Schrodinger's rabbit.
Both literal and not.
Wow. Some very dark puns happening here.
Yeah. I think people are ready for dinner if I read the chat correctly.
No, they can't go to dinner. They have to go to the BOF first.
Yes.
Yeah.
It is time to go to a BOF.
But you do have a short time to heat up some queso, bring it to the BOF with you, and then you can see if your queso is better than Julie's.
Yeah.
Get some queso tips from everybody.
Or just bring a bowl and go to the queso fountain that's right there in the BOF. That's what I'll be doing. You'll probably see me licking it off my arms. Should I admit that in public?
You can.
And people are asking about t-shirts. If you look in the Slack, you'll find link for t-shirts. You can also find the BOF links there, even though Julie just shared it in case of emergency here. But
if you fall into the queso, will it be like quicksand? Is it quick queso? Will you be able to get out?
It's queso sand.
Eventually you get out, but with queso, the longer it sits, it congeals. So it gets much more difficult.
So yeah, don't get stuck in the queso because the viscosity might, affect you negatively.
Yeah. The Reynolds number gets worse.
Oh no.
Wait, stop.
Clearly, this is what my degree is for. Is queso viscosity.
Yeah. This is the mean free path of a photon through queso.
Ooh, what about neutron queso? I'm ready. Consider a spherical queso.
The problem is it's too heavy.
Well, so what I'm doing, if you check out, I have a package poly queso that's for simulating the dynamics during the congealing process. I'll be giving a lightning talk about that. Is anybody left, or I'm just talking still?
We saw 180 people listening to you.
I'm so sorry for them.
Yeah. Well, it really seems like you were warming them up, for.
I hope so, so that the cheese will uncongeal and they can escape from the queso.
Exactly. We're getting them ready for going into the gather town, ready for the queso.
Yeah.
But now we have to make some tortilla jokes. We've really left out the queso vehicles.
Right. They need some representation as well.
Yeah. So I guess if anybody has ideas, send us some jokes.
Yeah, just there's the lightning talk Slack channel. We need to use that for really important discussion topics like how to make puns about tortillas also. So
yes, join it. Okay, should we end it? Should we end this actually?
Oh, is there a button that I press?
Yeah.
Yeah.
Are you?
Oh no.
Oh no.